Okay, so in this video clip, we're going to set out some pivot tables for Kings County house price data set. It was originally set up this Google Colab mainly to perform machine learning. I'm just going to add in here a little bit in relation to pivot tables and just build in some functionality in terms of the pivot tables. Now it's a little bit further down in our data set, but basically pivot tables are typically used in Excel. They're a great way of summarizing with a smaller table the data contained in a much bigger database or spreadsheet. So Pandas provides this type of functionality, and we make use of the pivot table function. And down here, we'll introduce a few examples just to demonstrate some of the flexibility we're able to extract from the pandas by using this pd.pivot underscore table. Okay, so to get this Google Colab notebook, Python notebook up and running, we've got to load in some data. We can get the data from here. I've left a hyperlink. There's 21,600 X number of rows here, so it's quite a substantial one. You can download it by just hitting this. I've already downloaded that CSV file, but now I want to bring it into this Google Colab environment. And just to note, the working directory is the content folder. And maybe if you don't see where the content folder is, typically you just look over here. If we were in our table of contents, you would come here, and then you would look for the content folder. So to upload, then we find where we downloaded our data. I've put it into my data folder here already. This is a CSV file. Just check that that's correct. It is a CSV file, and we can upload. But the original source is here. You can download that file, then extract it. I'll load in some libraries, and then you'll have it here in your. Make sure it's in the content folder, and then you can read it in. And once it's read in, then you can pull out then the first 10 rows, or if you want, you can pull out the first 20 rows. And again, we're using the pandas right here in Python to read in that file from here, the content folder, and we're calling it df, right? So df head 20 will give us 20 rows. Now, we've already looked at this in previous collabs and in previous video clips. I can leave links to those underneath. We can do some descriptive statistics. So we get a count, a mean, standard deviation for each. There's quite a few. If we get the information here, if I put in, let's just see. If we take df.info and open bracket, close bracket, right, we get some sense of what's in there. All the cells are populated, it would appear. And we could also get maybe df.shape, right? And if we execute that, so it's got 21,613 rows and 21 columns. Okay, so a lot of data. Now, what we want to do is I'm going to skip through each of these areas, and I'm going to go straight into the pivot tabling. And I'm going to introduce, first of all, the pivot table by just doing a very simple pivot. And that is, I'm going to split up our data. If we took a look at our data here, what we might notice that there was some properties that were waterfront. So out of the 21,600 and so properties, 21,450 are not waterfront, 163 are waterfront properties. They tend to be a little bit more valuable because it's a simple 0-1 binary. We can run a pivot table that compares directly the waterfront properties against all the others. So 0 waterfront would mean not a waterfront property. And then 1 would indicate it is. So if we execute that, run it, you can see straight away we can divide up. Also, it should be noted here with this pivot table syntax or function, right? It's going to default. The values that are reported here are defaulting to the median, right? So even though I haven't put in explicitly here any reference to getting the median value, we're getting the median, sorry, the mean. So we're getting the mean value. So it defaults to mean, not median, it defaults to mean. We're getting the mean number of bathrooms for each category. So waterfront properties, roughly the same in terms of bathrooms, bedrooms, condition, floors. But can we see something in terms of price? And we can, because that's where the big difference opens up. Waterfront properties, the average value is 1.6 million, whereas with non-waterfront properties, so properties that have no waterfront, 531,000. So that's a very significant a difference of €1 million, in fact, over €1 million difference, right? Now, waterfront properties are few and far between, so we can't draw very strong conclusions, but it is fairly suggestive here that waterfront properties are more valuable, right? Okay, if we were to put in explicitly this ag function equal to NP mean, we're getting using the NumPy library that we loaded in. You can see the values that come out here the same as what we have here. So these are really average, and this demonstrates, right, that when we do explicitly say we want to get the average value or the mean value, they are the same as the default here. Okay, we can say, okay, let's do the same again, but let's get the median. And when we compare the median value, it's the typical as opposed to the average. It's the typical. So what we would typically observe. Now, typical latitude and longitude doesn't make sense, and probably typically ID makes no sense, or average ID makes no sense at all. So some of these, it just doesn't make sense to include references to the all 21 columns here. Later on, we'll target a little bit better so that we're not going to be overwhelmed with nonsensical information. We'll just get very precise information that we retrieve from the criteria that we set out in the pivot table. But it's very clear the waterfront, if we take the median value here, the median price of property for non-waterfront property, 450,000. For waterfront property is 140,000. It's 1.4 million. Right? Typical waterfront properties have 2 floors. Typical non-waterfront properties would have 1.5 floors. So that would be like maybe a partially renovated loft that has an upstairs, but not 2 floors. Right? Okay. Something also that we might like to do, instead of just setting out just the waterfront or not, we could, in the index, here in terms of our row, set out waterfront property condition 1, 2, 3, 4, 5, or non-waterfront property condition 1, 2, 3, 4, 5, and waterfront properties condition 1, 2, 3, 4, 5, and then come over and we could look at the prices for each of those, or the median price. And if we run that command, you can see by adding in that extra index, we can build in an extra dimension into our data, so that specifically if somebody wanted a waterfront property and its condition should be 3 or 4, an auctioneer or a real estate, a realtor could say, look, we could guide you here, the price should be this range. Now, because the numbers are so few, right, we're getting maybe the price goes quite high for condition 2, but drops for condition 3. Seems to go down again, condition 4. Doesn't make complete sense, but I think it's just so few numbers involved here in the, I think it's 165 waterfront properties, that we're getting a little bit of aberrant or anomalous behavior. But the pattern we would observe here for the non-waterfront properties, condition 1, 2, 3, 4, 5, we can see a reliable trend increase in the value of the property as the condition improves, right? Maybe if we put in the grade here, we might be able to see something as well, but maybe not. Again, we've too few. If I put in grade, which is another condition of the property, might be how it is in terms of its physical condition, but the grade is a more broader kind of index of how good the property is, and it goes from 1 to 13. And we can see as the grade increases, we don't have any grade 2 for here would appear, but 3, 4, 5, there seems to be a reliable increase in the median properties, right? Median price for the properties as we increase the grade here. And for the waterfront properties, we don't have complete index. So for waterfront properties, the grade, none of them score a grade below 5, right? And does the price go up? Yeah, the price seems to be going up here as we increase as the grading increases here. We get a linear, not a linear, but we get what we observe here is proportionate or a positive, definitely a positive relationship with the grade. So the median price for waterfront properties increases as we increase the grade, right? Okay, now we could go again and we could say, look, but I just want values. I don't need all this information. And clearly it makes no sense that I'm getting the median latitude and longitude. That probably isn't going to be that useful right here. And I don't know how you would really interpret that. Possibly there's a way, but I doubt it. And you might be more targeted in your output. So you would say, look, I want to look at properties in terms of those that are waterfront and not waterfront. And then I'm going to set out, I want to observe the condition of the property on that, on the basis that we have 1, 2, 3, 4, 5 in each instance, and then report out the median price, the median square footage, and the median number of floors, right? And when we execute that, what we observe is definitely the price goes up, and the pattern is quite reliable as we increase the condition for the waterfront, non-waterfront property. So the 0 would mean it's away from the waterfront, and the square footage, yeah, kind of goes up, then goes down, and what we're seeing is that as the condition increases here, property size probably going up, but it peaks at 3, then down a little bit, right? And that's square footage, right? And then when we look, but the price is definitely going up. When we look at the condition and the floor, number of floors and the price, this one is, it goes dramatically up and then down and then down again and then up, right? And again, we said if you put in grade here, the pattern that we observe is more reliable. Again, consider what's going on here in terms of the pivot table, right? The syntax we're using is we have the index and then we want the values presented out and we want the median values, right? So again, when we look here at the grade, it's fairly clear that as the grade goes up and there's a 1 to 13, the value, the property is going up, right? It would appear, right? And then here, and these are the median values. Okay, so these are the median values for the property. We could also put in, and we'll do that in a moment, but the trend is that as we increase 1, 2, 3, 4, 5 up to 13, the value of the property seems to be going up. And likewise here, right? It is, the trend is fairly clear that as we increase the grade, it seems to be a reliable relationship between the grade and the value of the median price of the property. Okay, now we could also do, for instance, I don't want maybe the median, maybe I want the minimum, right? And let's see what's here. And maybe we're looking for, we want a waterfront property and a grade of 5. What's the minimum price? And there is one there for 285. There is the cheapest one there is 285,000. And the cheapest waterfront property with a grade 12 is 1.6 million. And it's that level of square footage. So as a realtor, maybe trying to figure out, pick out a property with an attractive price point. If price is something that is customers keen about, but also is making it fairly clear we want maybe 10, 11, 12 grade, and it's got to be waterfront. You can pick out the cheapest property here from your pivot table, right? It's something that is, and again, you could also put in, if you want to get the ID of the property, then say, okay, comma, so ID, there is a ID, and then that'll report out. So we can get the ID of the property for looking for the minimum, right? We can say, okay, what's the ID of the property? And once you find the ID, then we can locate the property. Okay, so this is a very nice way. Again, if you want to go for the maximum property, right? If you're selling a property and you want to communicate to a seller the best price, and in terms of prices that attracted, what properties attracted the highest price for a particular grade that was not waterfront or waterfront, we could do the same, and we can pull out the ID, right, for that. So these are very powerful ways of summarizing the data and communicating the data to a wider public now, or to target in on specific data and describe what's there. If we increase the dimensionality, if we increase the number, so here we have 2 dimensions. If we augment that, right, and we say, okay, we want waterfront, so waterfront or not, and then we want to break down by condition, going from typically 1 to 5, and then we want to look at the number of floors. So for each category, the number of floors, we've expanded, we're multiplying typically by a factor. If there's 5, 6 floors, I think go from 1, the maximum, up to, we can check from above here. When we looked at, with this command in the pandas, just bring it down. When I introduce this, execute this lines of code in the pandas, we can have a look at the floor space, or sorry, the number of floors. And let's come down. Yeah, here. So we have 1, 2, 1.5, 3, 2.5. So the maximum here was 3 floors, 3.5 floors. The minimum was 1, and most are 1, it would appear, and then 2, and then 1.5 floors, so in between, and then 3 floors, and so on. So we have 1, 2, 3, 4, 5, 6 categories here. And so when we introduce the third index into our pivot table, we are in effect perhaps multiplying by as many as 6. So for each category that we have developed here, based on the indices, when we have another 6 possibilities here, you can see how quickly, by introducing the third dimension, the third index, that we scale up fairly dramatically. That could be a problem, right? But it's something that's there, and perhaps there's a way of reading it. And if we needed to save that and share it, we could use this, take the name of the object we had created. So remember, the name of the object we refer to as table MP. So it's a pivot table with multi indices, and I could save it out somewhere that's convenient. It's going to go into the content folder. And if I close the content folder and open it back up again, you can see it's here. If I want to download, it can be done, and we can take a look, right, to see what's in there. And okay, that's what's there, right? So we started off with 21,600 rows of data. We have 37 rows of data here. That might be useful in some respect and maybe not, but you can see how we can, with a very big data table or spreadsheet, condense it to maybe 10 rows, 5 rows, 15 rows, 20 rows, whatever, right? And that gives us a very nice way of summarizing our data. But of course, it's probably a bit big, and maybe we just want to look at waterfront condition and just price and the median price. So if so, we take the dual index that we set out here, and then we're saying report out the price, but the median value, the median price, right? Or again, if we want to do that, condition and maybe put in perhaps, you know, grade or something like that. Maybe put in grade instead of condition. GRADE, right? And execute that. You can see we have condition 1, grade 1 to 13, and we can look at the price of the property. It's going up in a reliable fashion, and likewise as well, the price is going up in a very reliable fashion as well. And we can see this is 3 million, this is 1.7 million. There's a difference between 2.9 million, should I say, and 3.1. So there is a difference. We could take the minimum and the maximum as before. Let's take the maximum, run that, and we get some value here. Okay, and then if we wanted to have more than just one column of data, what if we wanted to have 2 sets of values reported out? Take the median value of each, the median number of bathrooms for each of these properties. So if you're specifying non-waterfront and the conditions 1 to 5, and then the median bathroom, number of bathrooms, median price, we can extract that. We could say, look, we want the same data again, right? So waterfront, if I revert back to grade, let's say for sake, GRADE, okay, we would have had the value, so the grades and the waterfront, and then we have the pricing for each. And we could do the same again, waterfront grade, but I want to set out then the condition. So I want the grades appearing here along with the index waterfront, but then for condition 1, condition 2, condition 3, condition 4, condition 5, and then get the median value. And that might be revealing then in terms of presenting us. So we have now a matrix, if you like, and we can say, look, I want to consider, and it's not a waterfront property, I want a non-waterfront property. It should have condition of 4. Sorry, it should have a grade of 4 and a condition of 3. Do we have a median price for that? We have 205,000. And then I can think of, okay, what's the minimum? So we were looking at 205,000. What's the minimum? MIN, put that in, execute. And you can see now the minimum here with the same criteria, 100,000. Okay, so again, if we have something very specific in mind, we want to target and reveal it, the pivot table is very powerful in doing that. And of course, we can also bring in a graph here to describe what's going on, and all the data that's summarized that we have here. We have a very nice way with this, loading this into our library, the matplotlib. We can graph using the ggplot style, and for each of the categories that we've set out here, we can determine what the prices are. Okay, so that's an introduction here to pivot tables with some graphing capability, and makes use of index columns, values, and then the type. Do we want a sum? Do you want a median? And so on. And pivot tables for that in the Pandas environment are very, very relatively intuitive in terms of how they're implemented and in terms of their interpretation. I'll leave it there.